So we can do the software upgrade manually as if like individual standalone switches with full-fledged downtime. Like just like a switch I'm upgrading, similarly 10 switches I would upgrade, and all of them basically are part of a VC. So that is a manual way of doing it. And the second one is NSSU, which is a high level available upgrade like ISSU. Normally when we have a backup soup engine or backup routing engine, how do we do? Right? We use ISSU, right? A customized ISSU according to virtual chassis is NSSU, which is non-stop software upgrade. My say is, unless you test it, see, this is part of data sheet and it works. But if you see in production, right, your customer would expect like almost zero, because that is what ISSU or NSSU is supposed to deliver, right? But it would deliver only up to a particular level of the scale and throughput. So don't promise it like I would do NSSU straight away and enter and see like, hey, it didn't work properly. I would always say try to do it in a lab, because every case is like kind of a different case in this, right? So Wipro or AGC, DataSafer, you would be having tens of customers where you are supporting virtual chassis, etc. And every customer scale and the utilization is different. So if your customer insists on NSSU, probably replicate it first according to the scale that they are using. Only if it is done, then only promise that, okay, we will do NSSU. It is working and let's do, right? Because there could be a slight impact or a bit more impact as well. So this is something that I would do it like personally. See, I'm not from engineering, right? I'm not from marketing. I'm from operations and services. I always prefer more stability. Or if there is no stability, I prefer to acknowledge it and say like, let's not do it, right? So for that way, I would rather prefer doing manually. Tell him like, I am going to do manually only. Or let me test it first. And if everything is fine, then we go for NSSU. Let me give you a report first. Like I don't want to go into like a blind territory. Are we good? Yes. So according to the documentation, NSSU it would take more time compared to the direct upgrade, because it is a phased upgrade that tries to give the high availability. So it would be minimal disruption to the traffic. It is documented as well, minimum disruption. But what level of that minimum disruption is happening? Maybe you have to test once. Are we good? And to do NSSU, first thing is your switch cannot be in the virtual chassis. You cannot have 52 or 5110. Straight away, they don't even support NSSU. First thing. And after that, your entire VC should be on the same Junos release, and they should be in a ring architecture. Master and backup should be adjacent to each other. High available routing engine switchover features like NSR has to be enabled and stuff. So only when you are doing all this stuff, then you can go with NSSU, right? Which we call as a non-stop switching upgrade. Sorry, software upgrade. Then when we go to a VC, right, the members that you add, they would be given a member ID in an incremental way, right? These member IDs are like almost constant. They don't change. They survive reboots. You do reboot like 1,000,000 times. Probably there would be a hardware failure. But if your switch boots up, it comes up with a member ID 3 only if it is assigned once. So who can modify it? You as an admin can change it at any point of time, or in a VC, a master can change it. But once assigned, once this guy is part of a VC and he got a member ID 3, as long as he thinks that he is part of that VC, this 3 will not change again until admin changes it through configuration or operational mode command. Now, so why these member IDs? Why is such care taken care that this member ID doesn't change? Because those member IDs would now turn out to be your line card numbers or FPC numbers. So consider you have G000 on one switch. Now I have 10 switches and all 10 of them have G000. Now how do I uniquely identify them? On member 0, it is 000. On member 1, it is 100, 300, like that. So the member ID replaces the FPC number in case of your virtual chassis. Right? So they are just mentioning it here. So what would be the port number of this one? Normally it would be 000 and 001. Now because it is on member 1, it would be 100 and 101. Right? Now for this, the last two would be like, see, they mentioned that it is a 48 port switch. So the last two would be 46 and 47. Right? Now what would be the port name of this one and this one? Can somebody put the answer? Now, when it comes to the management, right, this is on the rear side view. Based on the device model, you may have these on the front side or on the back side. Okay, so this is on EX4300. Looking at the rear side view, it is EX4300. So on EX4300, right, the back side, the topmost port is your dedicated management port, which is called as ME0. It is used for out-of-band management, for taking SSH, etc. And on ME0, you cannot send transit traffic. So it cannot be used to reach internet, right? All that ME0 can be used is to access the device. You cannot use it like I send traffic on ME0, A, and what if B is connected on G001? It doesn't work because ME0 is used only for management traffic, not for the transit traffic. That's one. And when I form virtual chassis, right? So to which ME0 would I assign my management IP? I have like 4 ME0s. A moment later, I may have 10 ME0s. To solve this problem, what Junos does is, whenever a virtual chassis is being formed, all these ME0s on the back end will become L2 ports, and a inter-VLAN routing interface for that ports would be created, and it would be called VME. So now I assign my management IP to interface by the name VME, Virtual Management Ethernet Interface. Right? Now I can plug in my cable to anybody. I can plug in here or I can plug in here. Wherever I plug in, I get management access. Are we good?
Yeah, Pawan, but when I was doing it now in a QFX 5110, so I was assigning a IP to VME, but when I was connecting to routing table, the master route, the master routing engine, then only it was working, and when I was connected to a line card, it was not working. I was little surprised because as per the concept, it should work, right?
I think in that case, the management IP would have been assigned to ME0, not to VME.
As per my thing, like how far I remember, I did it in VME only.
Maybe you may not have yet committed it, because this is an expected behavior when you assign it to ME0.
Okay. So it's
what you said is
okay.
Correct. So the explanation that you have given is a symptom when you assign it to ME0 in a VC.
So is it something not like that? Okay, if I created a virtual chassis with the 5 switches, now at the later point, if I add the other one, it will automatically convert it to L2 port, right?
Yeah, it would automatically do.
Okay.
We need not do anything. So that is where, rather than assigning management IP to ME0, we simply give it to VME.
Okay, got that. Okay. I think I will recheck it once.
Sure. So just see, rather than seeing the configuration, right? Say show interface stars and see on which interface is the management IP coming up. That would give you a clear-cut answer.
Correct. Yeah, I will do that.
Sure. And then comes about the console port, right? So normally for one device, only one console comes, right? Now we have 10 console ports, and all these together are trying to act like one device only, right? So you can now plug in console to any port. It is not that console ports are specific to a switch, unlike IP addresses. So if I take console to a line card, I get access to line card only. No. You plug in console to whatever port, whatever switch, right? By default, all your consoles would be redirected to your master. So I may plug in console to master, I may plug in console to backup, or I may plug in console to line card. Basically any switch. Automatically, all my console connections would be redirected towards the master only in a virtual chassis.